Hey everyone, and welcome back. Today we are diving deep into a topic that, let's be honest, can be a real headache in SPM chemistry: redox reactions. But before we get into it, just a quick reminder that the absolute best way to make all of this stick is through practice. You can find tons of questions at www.mcqspm.com or on the MCQ SPM app. All right, you ready? Let's get you set to absolutely crush this topic. So, have you ever been in an exam, staring at a question, and your brain just goes blank, trying to remember which one is oxidation and which one is reduction? Yeah, you are definitely not alone. It's probably one of the most common mix-ups for students, but trust me, we're about to make it crystal clear. Look, instead of trying to memorize two different things at once and getting them tangled up, let's try a smarter approach. We're going to zero in on just one thing: reduction. If you can truly master what reduction is, well then oxidation is just the opposite, right? So let's win half the battle right here, right now. Okay, so what in the world is reduction? I want you to think of it like this. You have three special keys, and no matter what kind of redox question the exam throws at you, one of these three keys will unlock the answer. Let's get into the first key. So, key number one is the classic definition. Reduction is all about the loss of oxygen. You know how we get iron metal from iron ore? That ore is basically just iron atoms stuck to oxygen atoms, iron oxide. To get pure iron, you have to get rid of that oxygen. So the iron ore loses oxygen, which means the iron ore has been reduced. See? Simple as that. Now for our second key, which is pretty much the flip side of the first one, the gain of hydrogen. If a substance loses oxygen to be reduced, it makes sense that gaining hydrogen also counts as reduction. You might see an equation where sulfur reacts with hydrogen gas to make hydrogen sulfide, or H2S. What happened to the sulfur? It gained hydrogen atoms, so the sulfur was reduced. Easy. And here it is, key number three. This is the big one, the master key that works in almost every single situation. We're talking about electrons. And to remember it, we're going to use a super famous mnemonic: oil rig. Just say it with me: oxidation is loss. Reduction is gain. What are we gaining? Electrons. If something gains electrons, it is being reduced. Seriously, burn that into your brain. Reduction is gain. And this is where it all makes perfect sense. Think about it. Electrons have a negative charge, right? So if an atom gains something negative, what happens to its overall charge? It goes down. It becomes less positive. Its oxidation number literally gets reduced. That's why we call it reduction. It's not just some random chemistry term. It's literally telling you what's happening to the charge. It's reducing. All right, so we've got the theory down. We have our three keys. But let's be real. The only thing that matters is whether we can use them when it counts, right? In the exam. So let's take these keys and unlock a real past year SPM question. This is where we turn that knowledge into points. Okay, here's a classic one. You take a piece of zinc metal, you pop it into that familiar blue copper 2 sulfate solution. The question wants to know what's going on in terms of redox. Where do we even start? Let's just break it down step by step. First, who are the main characters in this reaction? We have solid zinc metal, Zn, and the copper ions, Cu++, floating around in that solution. Okay, step two, let's use our master key, the electron key. Now you know from the reactivity series that zinc is more reactive than copper. That means zinc is the one that's going to lose electrons. So where do those electrons go? Well, they have to go somewhere. They're picked up or gained by the copper ions. And what does our mnemonic oil rig tell us? Reduction is gain. So our conclusion? The copper 2 ions are reduced. Boom. And just to prove it, here's the official explanation. It confirms our exact thinking. The copper ion, which started with a charge of +2, gains 2 electrons and turns into a neutral copper atom with a charge of 0. Its oxidation number was reduced from +2 down to 0. It's a perfect application of our rule. Okay, so solving one question is awesome. But to really ace this section, you need to think like an examiner. You need to see the patterns in how they ask these questions. Let's look at what they're really trying to test when they give you a redox problem. So you'll see a few common types of questions. Sometimes they'll just ask you for a straight definition, so you got to know your three keys. Other times you'll have to analyze an equation. But listen up. Here is the #1 trap that so many students fall into, confusing the thing being reduced or oxidized with the agent. Just remember this. The substance that gets oxidized is the one that causes reduction in the other substance. That makes it the reducing agent. It's the opposite of what it sounds like, and it's designed to catch you out. Don't let it. So there you have it. We've gone through the theory, we've got our 3 secret keys, and we've even looked at the exam strategy. Now comes the most crucial part, the part where you make this knowledge permanent. It's your turn to practice. Look, watching this is a great first step, but it's what we call passive learning. To really truly lock this in and secure that grade, you have to do active practice. You need to get your hands dirty, try the problems, make mistakes, and learn from them. That is the real secret to getting that A+. So here's what I want you to do. Pull out your phone right now, scan this QR code, or just type in www.mcqspm.com. It is loaded with hundreds of real past year questions on redox and every other topic. Use what we just talked about and put it to the test. This is how you're going to walk into that exam feeling totally confident. So I'll leave you with this thought. The next time you're sitting in an exam and a redox question comes up, are you going to feel that moment of panic? Or are you going to remember you have the keys to solve it? You've got the 3 definitions. You've got OIL rig. You know what to do. You've totally got this. Good luck with the practice, and I'll see you next time.